All right, get ready to shrink down to the nano level, everyone, because today we're taking a deep dive into the fascinating world of quantum dots.
These tiny particles are making a big impact everywhere you look, from those super vibrant TVs to cutting-edge advancements in medicine. It's incredible.
You know, when I hear quantum, I usually think of, like, spaceships and teleportation, but we're talking about tiny dots here.
Well, they might be small, but they're definitely powerful. And it all starts with something surprisingly familiar: color.
Okay, you've got my attention. I'm always up for a good color story. We're talking tie-dye watercolors.
Not quite, but you're on the right track. We're actually going way back in time to explore the science behind colored glass.
Wait, seriously? Like stained glass windows, those things have been around forever.
Exactly. It turns out that ancient technology holds the key to understanding these incredible quantum dots we're talking about today. For centuries, people have known that you could add certain materials to glass to create vibrant colors.
That's true. I have this beautiful stained glass lampshade. It's got these swirls of blues and greens. Never thought of it as high-tech, though.
Well, it wasn't until the late 1970s that a scientist named Aleksey Yekimov figured out exactly why this happens.
Ooh, a scientific mystery. I'm intrigued. Tell me more.
So picture this. Yekimov is in his lab, peering through a microscope at a piece of glass infused with copper chloride.
Copper chloride. That's like chemistry class all over again. What was special about this glass?
Well, he noticed something really peculiar. The size of the tiny copper chloride crystals actually changed the color of the glass.
No way. So like smaller crystals meant the different color than larger crystals?
Precisely. Smaller crystals, bluer light absorption.
Yeah.
Larger crystals, you get more of that typical copper chloride absorption. This was a huge deal because it demonstrated for the first time that you could actually change the behavior of a material simply by manipulating its size at the nanoscale.
Hold on, nanoscale. Just how small are we talking here?
We're talking billionths of a meter.
Whoa. Okay, that's seriously small. I always knew size mattered, but I had no idea it was that dramatic.
So is this to say that Yekimov accidentally invented quantum dots?
He did, essentially. At least he created them without realizing their full potential. But here's where it gets even more interesting. Around the same time, over in America, another scientist named Brus was making a similar discovery, but with particles suspended in liquid instead of glass.
Get out! Two scientists on opposite sides of the world working on basically the same groundbreaking idea. That's incredible. Were they like comparing notes or something?
It really is a remarkable case of scientific synchronicity. And no, they were working totally independently. Brus was studying cadmium sulfide particles, and he observed the exact same thing as Yekimov. The size of these particles directly affected how they interacted with light.
So like bigger particles meant one color and smaller particles another color. Just like those tiny crystals in the glass. Exactly. Smaller particles, a blue shift in the light they absorbed, just like those tiny crystals Yekimov was looking at. They were both piecing together the same puzzle from different angles.
So we've got these two scientists, Yekimov and Brus, separately discovering this incredible link between size and color at the nanoscale. Sounds like we're on the verge of a major scientific breakthrough.
Absolutely. But there was still a major hurdle to overcome. The quantum dots they could make back then were a bit inconsistent, let's say.
Inconsistent how?
Imagine a bag of M&Ms where you want them all to be the same color, but instead they come out all different sizes and shapes.
Okay, so like a quality control issue, but at the nano level. So how did we go from a jumbled bag of nano M&Ms to the precisely engineered quantum dots we have today?
Well, that's where our third Nobel Prize winner, Moungi Bawendi, enters the picture.
Ooh, a third character joins the story. This is getting good. What did this Bawendi fellow bring to the table?
He revolutionized the field by figuring out how to grow those quantum dots with incredible precision, creating large quantities of uniform, high-quality quantum dots with amazing consistency. It was a total game changer.
So instead of crossing their fingers and hoping for the best, Bawendi found a way to control the entire process.
Precisely. His breakthrough opened up a whole new world of possibilities. It's like he figured out how to speak the language of the nano world, and suddenly we could communicate with these tiny particles and control their amazing properties.
Now that's what I call a scientific mic drop. We've gone from ancient colored glass to these precisely engineered nanoparticles, all thanks to the ingenuity of these brilliant scientists. It's like the universe was hiding a secret code in plain sight all along, and they cracked it wide open.
And you know what the best part is?
What's that?
This is just the beginning. Now that we have this newfound ability to control quantum dots, the applications are practically limitless. But we'll dive into all that amazing stuff after a quick break.
Okay, so before the break, we were talking about how scientists figured out how to make these, like, perfect quantum dots, and now we can control them and stuff.
Exactly, and that's what's paved the way for some truly mind-blowing applications.
Okay, so let's talk about those applications then. Like, what kind of cool stuff can these tiny dots actually do?
Well, for starters, they're the reason your TV looks so incredibly vibrant and lifelike.
Wait, really? You're telling me those quantum dots are actually inside my TV right now?
They are. If you have a QLED TV, those vibrant colors and that crystal clear picture you're enjoying are all thanks to quantum dots hard at work.
Wow. I had no idea.
Okay.
So walk me through it.
Yeah.
How do these tiny dots actually make my TV look so good?
Remember how we were talking about how the size of a quantum dot determines its optical properties, how it interacts with light?
Yeah, like the whole smaller dot, bluer light, bigger dot, redder light thing, right?
Precisely. So in your QLED TV, there's a backlight that emits blue light. Some of that blue light passes through a layer of teeny tiny quantum dots, each one precisely engineered to a specific size. And based on their size, they convert some of that blue light into incredibly precise shades of red and green.
So each quantum dot is like a mini, super precise light filter, making sure the colors on my screen are perfect.
Exactly. Because we can fine-tune those dots to emit such specific wavelengths of light, we get a much wider and more accurate range of colors than with older TV technologies. That's why those nature documentaries you love look so incredibly vivid.
Okay, that makes so much sense. I knew there had to be some serious science behind those stunning visuals, but I never realized it was quantum dots. And to think, it all started with colored glass. That's wild.
It really is. And the best part is, because quantum dots are so incredibly efficient at converting light, QLED TVs actually use less energy overall, so it's better for your electricity bill and the planet.
Wow, that's what I call a win-win. I'm starting to think these quantum dots are too good to be true. What else can they do?
Well, they're not just transforming television. Believe it or not, quantum dots are also being explored in medicine.
Quantum dots in medicine. Now, that's something I never would have guessed. What are they doing? Like curing the common cold?
Not quite, but they are showing incredible promise in areas like cancer treatment.
Quantum dots can help fight cancer. Okay, now you're really blowing my mind.
It might sound crazy, but it all comes down to their remarkable ability to act as incredibly precise tracking devices. Remember how scientists can attach them to biomolecules?
Right, like tiny glowing backpacks for cells, right? But how do those quantum dots actually help with something as serious as cancer?
Researchers are exploring ways to use them to improve the accuracy of tumor removal surgeries. It's really quite incredible.
Okay, you have to tell me more. How does that even work? Do surgeons like wear special quantum dot goggles or something?
Not exactly. It's all about creating what scientists call targeted imaging agents. They basically attach the quantum dots to specific molecules that will bind to certain cells or proteins found in tumor tissue.
Oh, so it's like creating a homing beacon for those cancerous cells.
Exactly. And because these quantum dots emit such a bright light, they act like little beacons, illuminating the tumor with incredible precision.
So it's like giving the surgeon a roadmap to the tumor, helping them see exactly where to operate.
That's a great way to put it. It allows for a more effective tumor removal with less damage to the surrounding healthy tissue, which is a huge win for cancer patients.
That is absolutely amazing. And to think, it all started with scientists just trying to understand why glass changes color. It just goes to show you the most groundbreaking discoveries can come from the most unexpected places.
You know, you're absolutely right. And that's just scratching the surface. They're using quantum dots to make more efficient LED lights and even exploring their potential in solar energy and quantum computing. It's a truly revolutionary field.
I can't wait to see what incredible advancements they come up with next. This nano world is pretty darn amazing.
It really is. But speaking of amazing, have you ever wondered what it would be like to control the properties of any material just by manipulating its size at the nanoscale? It's mind-blowing, isn't it? From those vibrant TVs we were just talking about to potentially revolutionizing cancer treatment, it seems like there's no limit to what quantum dots can do.
It really is amazing. And to think it all started with scientists simply trying to understand why glass changes color. It makes you wonder what other world-changing discoveries are hiding in plain sight, just waiting for someone to connect the dots.
Absolutely. It's a testament to the power of scientific curiosity. But let's shift gears for a moment and bring it back down to earth. We've covered a ton of ground today, from the history of quantum dots to some pretty mind-blowing applications. But I'm curious, for the everyday person listening, why should they care about all of this? What's the big takeaway?
That's a great question. I mean, it's all fascinating, of course, but how does this nanotechnology actually impact our lives?
Well, for me, it boils down to this. Quantum dots have the potential to help us solve some of humanity's biggest challenges.
Okay, like what? Give me some examples.
Imagine a world powered by incredibly efficient solar cells, fueled by our newfound ability to manipulate light at the nanoscale. Or medical sensors capable of detecting diseases like cancer at their earliest stages, paving the way for more effective treatments. The possibilities are truly staggering.
That would be incredible. A world running on sunshine and early disease detection, thanks to quantum dots. Sign me up. But like with any powerful tool, I imagine there are still some hurdles to overcome, right?
Absolutely. One of the biggest challenges right now is cost. Producing those high-quality, super-efficient quantum dots on a large scale can be pretty expensive, and some of the materials involved aren't exactly environmentally friendly.
So it's a balancing act between pushing the boundaries of scientific innovation while also considering the environmental impact.
Precisely. It's about ensuring that these incredible advancements ultimately benefit both humanity and the planet.
Well said. As we wrap up our deep dive into the captivating world of quantum dots, what's one final thought you want to leave our listeners with today?
We are standing on the brink of a nanotechnology revolution, and quantum dots are leading the charge. So stay curious, never stop asking questions, because who knows what amazing discoveries are just around the corner.
I love that. A call to action for all our curious listeners out there. Keep those brains engaged and never stop exploring the wonders of science. From glowing TVs to the future of medicine, it's clear that big things are happening in the nano world. Until next time, happy learning, everyone.